Well, this is topic 8, lesson 2, the first example, try it. Here's the thing. I'm not really noticing tools on Pearson that are helpful. I mean, there is that wrench up in the upper right-hand corner, but I can't figure out how to use it. So I'm going to research some other places for a second and see if there's something that's going to help us more. I have a couple ideas. I'll be right back. If I can pause this, I'll get back to you on that. I just sent an email to the person in charge and we'll see what we can do. In the meantime, there is a whole lot of vocabulary here, right? Quadrilateral. A quadrilateral means it's a four-sided shape, quad. Two equal sides that meet at a right angle. What I hope that you do on these activities is maybe get out a piece of paper and draw it until I can find the right website for you to use. Equal sides, same length, and a right angle means 90 degrees. If you were to just sketch it, and do your very best, I'm going to try, don't judge me. I'm going to try to make two lines here that are meeting at a 90-degree angle that are equal lengths. The way that geometry people show equal lengths is they put matching tick marks on them. Then it says, and those are tick marks, there's 2 tick marks on each line. Then it says non-adjacent angles. What a weird word. Non-adjacent. Adjacent means next door. So your adjacent neighbor would be your next door neighbor. Non-adjacent means they're not next door. So non-adjacent angles, we could make an angle here and we could make an angle there. Both of those red marks are adjacent to the 90-degree angles, but they're not adjacent to each other. And we want to make them the same measure. So if we used a protractor and we were to draw like an angle coming out that's kind of more than 90 degrees and do the same one over here that's more than 90 degrees and then keep going until they meet each other, the shape that we drew would end up being a kite. K-I-T-E. Kite, like a kite that you fly. There's a lot of things that we could draw. Oh, hey, I can draw straight lines. Oh, that's nicer. I'm going to draw another one. I'm going to say that these two guys are the same length. I'm going to put 1 tick mark on each. And then, of course, this guy is 90 degrees. Oops. Oh, I've got the straight line thing turned on, don't I? This is 90 degrees, and I'm going to show that by putting a little box there. And then I want equal non-adjacent angles. So what if I were to draw a side coming out this way? Let's try that again. A side coming out this way that's coming off of this angle also at 90 degrees, and then another one coming off 90 degrees from down here. And you only really need to go until they meet each other. But let's pretend that this one is also at 90 degrees. And then what shape would that be? And actually, that shape ends up being a square. So you could have ended up drawing a square. A third one that you could have done, we start again with 2 equal distant, same length sides meeting at a 90-degree angle. And then they're non-adjacent angles. Once again, that's this guy and this guy. Those are the non-adjacent angles. Watch what happens when I do this. This is kind of weird. So I'm going to have this angle be an acute angle, and I want this one to be the same size acute angle. And it ends up, you get the idea, it ends up making that shape, which is also a quadrilateral. These are all quadrilaterals. They all have 4 sides. And that's just kind of a little funky drawing there, which, we'll talk about at a later date. But there's 3 possible things that you could draw. And again, I'm looking for a website where you can do this electronically. But if you have a ruler and a protractor at home, those also work. So my favorite thing to use when I'm trying to measure a 90-degree angle, which is I feel like it's kind of cheating, but whatever. Sometimes when I need to draw a 90-degree angle, I'll use a piece of paper or a Post-it note, and I'll put it down, and I'll just trace along this edge, and then I know it's a 90-degree angle. Okay, that was example 1. Try it. Example 2 is another one that didn't have a try it on there. But here are 2 different ways that Mr. Miller could have arranged the desks to seat 10 people. In the first one, he needed 8 desks to make that happen. In the second one, he needed 14. And those were just 2 examples of how to do it. And I think that the way that they gave you to do it is to actually drag and drop, which is kind of fun. And then to put these circles around as seats for each, which is sort of interesting too. So I liked that example, but it didn't have something where you had to try it. So let's move on to example 3. Okay, everybody, you're going to have to bear with me on this one. This is example 3, try it, from 8-2. In the first one, you're just supposed to show another way that you could build a sketch, or you could build the desks to seat 10 people. You could have 10 individual triangles. Well, no, I guess not, because that would seat more than 10 people. But you could have made like 2 trapezoids out of the triangles. Each trapezoid would have 3 triangles in it, with 5 people around each one. That doesn't make sense, does it? I'll show you later. Okay, but the second one is what I want to talk about. We're supposed to use geometry software to make a rhombus with a side length of 6 units and 2 angles that measure 45 degrees. So first of all, a rhombus, it's sort of like a square. All 4 sides are the same length. What makes it different from a square is that the angles are not 90 degrees. So a lot of times people will see what's actually a rhombus and maybe call it a diamond. But rhombus is the name for it. We want the sides to be 6 units and 2 of the angles to be 45 degrees. So my guess is it's going to end up looking like, whoops, not like that. It's going to end up looking like this a little bit, where all 4 of these sides are 6 units, and this angle here and here are both 45 degrees. But we're supposed to use geometry software to do that, and it's not easy. So you bear with me, I'll bear with you. So if I go to Math Tools up here, and I choose 2D geometry, 2-dimensional geometry, and then I choose building figures. So let's try it. I am going to drag this to the side here and bring back up the example because it's sort of, what did I do? Hello. It's hard to draw it and not be able to read the description at the same time, so that's why I'm doing it this way. So down here, I'm going to go to quadrilaterals. I'm going to choose rhombus, and I'm going to put it somewhere on my screen. So, and then this arrow allows you to sort of move it around a little bit. So we have to make the angles 45, 2 of the angles 45. So let's choose angle D and B to be the ones that are 45. So the way we're going to do this is to measure angle D. We're going to choose the measurement tools. And in order to measure angle D, the D part has to be the middle. So this angle is created. What if I just clicked it? No. Okay, you have to select 3 points. All right. How do I undo that? Oh. Oh. What? I want the side length to be 6 units? I didn't know I could do that. And is there a way for me to change the angle? Wow, I'm just learning new things all over the place. Okay. How do I undo selecting this guy? Okay. I don't know how I did that, but let me push pause. Okay, I'm going to do it the other way. So I'm going to go to rhombus, draw a rhombus. I'm going to use the inspect, and in order to choose angle D, you have to choose 3 points. So the points that make angle D is the line that goes from A to D and then from D to C. So we're going to select A, D, C. And that's going to tell us how big angle D is. And right now, angle D is 34.92 degrees. Okay, now the other thing we need to do is make the side lengths 6 units. And because it's a rhombus, all 4 sides are the exact same length. So if I go back here to inspect, and I'm going to click on any one of the sides, I'm going to click on side CB like that. So right now, that side is 5 units. So here's the tricky part. We're going to grab one of the angles, or maybe more of them, and we're going to move them around and try to get the measurements we want. So by dragging it here, I've made the side about 6 units. And then the angle is too small, so I'm going to grab C and pull it and make it bigger. So I'm going to try to get it to 45 degrees, which I did about. But now the side length is too small, so now I got to grab this and bring it in a little bit. But when I did that, it made this angle bigger. So I'm going to adjust the angle, and I'm going to keep going back and forth until I get as close as I possibly can to the angle being 45 degrees and the side length being 6 units. There are easier ways to do this, but for right now, we're going to do it this way because there's lots of, this is the part where I wish we could have a discussion with each other, because there's lots of things that we start noticing, like as we bring point B in, what happens as you're bringing this in, the angle itself is getting bigger and the sides are getting shorter. And as we bring it out, as we pull it out this way, the angle is getting smaller and the side lengths are now getting larger. So those are the kinds of things that make me so sad that we're not together to talk about, because there's a lot of really cool math things happening here. So I'm not a huge fan of this particular geometer, the sketch pad. I'm looking for another one that I think will work better, but I want to find a free one so we can all do it from home. Anyway, that is how to use the software to make that rhombus. Ooh, right?